This is Euclid Book 10, proposition number 73. But before this proof goes on here, there is actually some kind of a note, and it should have been attached to number 72, but I'll go ahead and read it for you. It says, the binomial straight line and the irrational straight lines after it are neither the same with the medial nor with one another. For the square on a medial, if applied to a rational straight line, produces as breadth a straight line rational and incommensurable in length with that to which it's applied, which is by Euclid Book 10, proposition number 22. But the square on the binomial, if applied to the rational straight line, produces as breadth the first binomial. This is by Euclid Book 10, proposition number 60. The square on the first bimedial, if applied to a rational straight line, produces as breadth the second binomial, which is by Euclid Book 10, proposition number 61. The square on the second bimedial, if applied to a rational straight line, produces as breadth the third binomial, which is by Euclid Book 10, proposition number 62. The square on the major, if applied to a rational straight line, produces as breadth the fourth binomial, which is by Euclid Book 10, proposition number 63. The square on the side of a rational plus a medial area, if applied to a rational straight line, produces as breadth the fifth binomial, which is by Euclid Book 10, proposition number 64. The square on the side of the sum of two medial areas, if applied to a rational straight line, produces as breadth the sixth binomial, which is by Euclid Book 10, proposition number 65. And the said breadth differs both from the first and from one another, from the first because it is rational, and from one another because they are not in the same order. So that the irrational straight lines themselves so the irrational straight lines themselves also differ from one another. Okay. Now I have absolutely no idea what all that's about, but you now know, and so do I, and let's just go on. Now we're going to present Euclid Book 10, proposition number 73, and as you can see, it is a much smaller diagram. Thank heavens. Too bad all these proofs aren't this small. Okay. If from the rational straight line there be subtracted a rational straight line commensurable with the whole in square only, the remainder is irrational, and let it be called an apotome. Now, if I mispronounced apotome, I'm sorry. I tried to look this baby up, and I couldn't find a single pronunciation anywhere. So if somebody finds a better pronunciation, by all means let me know. Thank you very much. Okay. For from the rational straight line AB, let the rational straight line BC, commensurable with the whole in square only, be subtracted. Okay. So, we have the rational straight line AB, and what we're going to do is we're going to subtract BC. Now, there's a special note about BC, and that note is it's commensurable with the whole in square only. So what that means, that this line is not commensurable with the whole AB, but if you squared this line and you squared the whole AB, then they would be commensurable. Okay? That's the note. Okay. I say that the remainder AC is the irrational straight line called apotome. For since AB is incommensurable in length with BC, and as AB is to BC, so is the square on AB to the rectangle ABBC. Okay. So as this whole length is to this small length, so is to this. Now where do we get this? Well, we took the length of AB, and all four sides of this square are going to be the length of AB. Now, where do we get this? Well, two sides of this rectangle here, two sides of it are going to be the length of AB. Two sides are going to be the length of BC. That's where we got it. So as this whole line is to this portion, so as this square area is to this rectangular area. That's what Euclid's saying. Okay. Therefore, The square on AB is incommensurable with the rectangle ABBC, which is by Euclid Book 10, proposition number, looks like 11 to me. Okay. So, these two areas are incommensurable. But the squares on AB and BC are commensurable with the square on AB. So, if you add these two areas together, they're going to be commensurable with the area in this square. Okay. This is by Euclid Book 10, proposition number 15. And twice the rectangle ABBC is commensurable with the rectangle ABBC. Okay. Alright. So, if you multiply this area by 2, it ends up being commensurable with just this area alone. This is by Euclid Book 10, proposition number 6. And inasmuch as the squares on AB and BC are equal to twice the rectangle ABBC together with the square on CA, okay. So, now we have to draw one more little box. So, what are we going to say this time? Alright. So, what we're going to do is we're going to add these two areas right here. That's the first step. That's what we're going to do first. That area right there is equal in area to something else. Now, what is this area? Now, we added up the areas of square AB and BC. We added those two areas up together. What is that whole area going to be equal to? Well, what it's going to be equal to is twice this area plus the area of this. So what you do is you take this area, you multiply it by 2, and then you add it to this, and that all combined will be the same amount of area as if you added this and this together. That's what he's saying. Okay, let's go on here. This is by Euclid Book 2, proposition number 7. Therefore, the squares on AB and BC, okay, are also incommensurable with the remainder, the square on AC. This is by Euclid Book 10, proposition number 13, and Euclid Book 10, proposition number 16. Alright. So, if you add these two areas together, they're going to be incommensurable with the area inside of this. That's what he's saying. Let's go on. But the squares on AB and BC are rational. So what it means is that when you add the area of AB and you add the area of BC together, whatever area you come up with is going to be rational. Therefore, the area of AC is irrational. This is by Euclid Book 10, definition number 4. And let it be called an apotome. So now you know what an apotome is. Okay. And that's our proof. I will tell you more in a future video. Stay tuned.